Hello, so my name is Chris, and I'm going to do a bit of an experiment. I'm going to talk about engineering stuff. Fairly in-depth. Yeah, oh, well, that's good. So some engineers here, I see. That's good. I apologize for everybody else that might think it's a little bit boring, but it could be quite interesting. So, yeah, Git and stuff. So I'm not going to tell you how to use Git, because you can go on the internet and find out how to do that. I'm going to dive a little bit into how Git works and how that actually quite elegant concepts that we can use for other things as well. But I want to start off by, and you see this is pretty minimal slides, black and white, simple font, and I even left out the quotes. I got this tweet on my Twitter at some point, and it says, "It blows my mind that people are still using Subversion. Do you catch your dinner by throwing rocks at it?" I think it's quite telling. I mean, Subversion is being developed further, and it's getting actually quite good. But I like Git, so I thought it was a fun thing to share. So what is Git? Git is a distributed version control system, or you could also see it as a distributed software configuration management tool, which is a little bit of the broader view rather than just versioning files. You can actually manage software releases and other sort of packaging with it. So I guess my goal is that by the end of my 5 minutes talk, I hope you get a little bit of the fascination I have with Git, sort of beyond just the two use cases here that are sort of the classical things. I need version control, so I look at Subversion, Perforce, and Git, and I compare them and find one for myself. So I can't explain how all of it works in 5 minutes, but I hope you get interested in it and maybe dive in deeper if you don't already fully understand what it does. So distributed is kind of the key word. It's distributed storage, meaning that your repository can be in multiple locations and they might not represent the same state. It's your responsibility to manage that. You can have a central server, do it more like Subversion, or you can actually work in a fully distributed way. But it's kind of up to you to move stuff around. But Git is a distribution tool as well, so it actually gives you great tools to distribute your data between those repositories. And another side effect out of this, which is actually quite interesting, is that repositories become sort of a first-class workflow citizen. They become a proper tool with which you can build workflows, because now you can create your own repositories on your systems. You can fork, you can clone. You don't need an admin to do this. There's no central instance that manages all repositories. Even if there is a central repository, that is your canonical copy of your game, for example. But what's under the hood? That's the really interesting part, I think. Under the hood, we got a content addressable store, a cryptographically signed chain of work, and an object replication or distribution protocol. So I think that's sort of the three key components that make up Git. And beyond version control, they're actually quite interesting. So starting with sort of the data store. A data store is basically a database, right? And a database is kind of like a dictionary. You got a key, and a key gives you a value. So you have a user email address, it gives you a user record for it, right? So when we're talking about content addressable stores, the concept is actually different. We're talking about you give the value and you get the value back, sort of. You store a value by its content. That seems a bit odd, but looking at it a little bit closer, it means that we retrieve information by its content, not by its location. So if you have a traditional database, you have an index of sorts or a key. That's kind of your address. It could be the physical location on your hard disk, cylinder 0, sector 1, right? That's where your data is stored. So if you want the latest headlines, the front page of the New York Times, we would actually have to give the front page of the New York Times to the database to get the front page of the New York Times. Doesn't make sense, right? That's a lot of data. So the first thing we could do to make this a little bit better is to use a hash instead of the content. And we're probably going to use something like a cryptographic hash function that creates a constant length hash for that. Cryptographic hash function is sort of a talk in itself, but the idea is that you create a unique key for your content. So if you make any changes to your content, that hash will change as well. And it's really hard to get from the hash back to the content. But now we still need to know the content to generate that hash, right? So if you want to look up something, some content, we still need to know the content. So how do we get to our data? And the way Git works is that it adds additional objects to the database that work more like traditional databases. So you have something where you have a directory object that lists all the files in that directory, and then you have a file object that says, I'm file name this, and my data lives in an object with hash x. right? Well, that kind of gets us one step closer. We now have a way to getting from one object to another object. But we still don't have a way in, because we still need to know the content of that file system object to get to its content. So what we also need is kind of an external list of sort of key entry points, right? A short list that just is a traditional key value store that says that name manages that object with that hash. And also we can always obviously iterate over the entire store just in random order, just going through all the hashes that we know and looking at all the objects if we want to check integrity of a database, for example. So how is that related to Git again? Well, it's basically exactly how Git works, right? Files become content addressable objects. It takes the file, creates a hash, stores it by that hash. It creates these file system tree objects, stores them in the database, creates a hash for it. And branches and tags, the things that we work with on the top level, they're just hashes themselves. So your develop branch just equals a hash. With that hash, you look in the database. It gives you an object for all the files that are in this commit. And then each file is an object in itself. So now we can actually traverse the system. So the cryptographic signed chain of work, I'm going to skip a little bit because we're already running at 6 minutes, I see. And I'm going to go straight to the object replication. Moving objects around once you have a content addressable database becomes actually quite elegant. If you want to know if two machines have the same data, you only need to compare if they have all the same hashes. Now we designed our hash function to be really short, constant size amounts of data, so it's really easy to exchange and send a list. These are my hashes, what are your hashes? Oh, you have that object, I don't have that one? Well, let's exchange those two, right? If we use a system like Git where we have objects that reference other objects and we have that knowledge in our exchange protocol, we can actually make that a lot faster. We can say, do all the hashes of all these root objects match? Which are just very few objects, right? If you want to see, do you have revision 0? Like, what's the hash of revision 0? Do you have that hash object? Yes. Well, then we don't need to exchange anything because you're going to have that as well as all the objects that it references. So that becomes quite elegant and very efficient. Git uses that basic protocol either over its own sort of Git protocol or over HTTP or over SSH, and uses data compression on top of that to make it even more efficient. So the takeaway really is looking under the hood is sort of quite fascinating. Look at the tools that Linus has chosen to build that system and looking how we can use that for other systems in our games. So the next obvious step kind of is like thinking about how do I store the objects of my game in a Git database rather than just using the file system, right? But what would I get from that? Well, we already learned it's quite easy to exchange data. So if I have something like downloadable content, comparing to a server actually becomes quite easy. Cryptographic hashes are a little more secure than just, say, using the file change state, right? And using that similar system to Git where you store the whole file system in it, you can basically map it to a Git repository on your machine. So if you do things like A/B testing, you can think of creating an A/B test as a branch and closing the test as a merge, right? And you just need to say, I'm on a specific revision with a specific hash, and you can transmit that to the device. Do you have the data? No, well, then you need to download stuff from the server, right? So Git provides all those basic functionality for you, and you have a whole chain of tools with it. So it actually becomes sort of using this content addressable store becomes quite an elegant solution for some of these problems. And it's actually worth looking at that, just from that perspective. So some links to kind of get started with Git. If you want to look at it as sort of a version control tool, which is definitely excellent for managing source code. For assets, you have to look a little bit closer if that's kind of the right choice. If you never used Git before, the Git sandbox is actually quite interesting. It's a GitHub operated site. You can type in some Git commands, see how that changes the repository. It's command line oriented, so that's not for everyone. If you want to have more of a graphical front-end source tree, something I would recommend. It's better on the Mac than on the PC at the moment, but Atlassian is working quite hard to get that up to speed. If you want to approach it from a book, the Pro Git book is quite good, goes through everything from start to finish. And if you're an engineer and you want to try some of these methodologies in your application, libgit2 is a good start to kind of get create procedural repositories, get access to revision, exchange objects, etc. from your code. So that's just a C++ rather a C98, I think, still library, ANSI C, so works with pretty much everything. And yeah, that's kind of my talk. Hope fun of the first engineering talks in this venue, and I hope it was interesting for you, so thanks for listening.